Well, my students, as I said in the previous lecture, we shall review the special relativity. Today we are beginning review of special relativity. Actually, special relativity is required because of the principle of relativity. What is principle of relativity? Principle of relativity says that all the laws of physics will be same in all inertial frames, and add with that the constancy of the speed of light. That means in every and all inertial frames, the speed of light will be the same, which we symbolize by c, which is equal to 3 into 10 to the power 8 meter per second. These two things, principle of relativity and the constancy of the speed of light in all inertial frames, gives rise to the Lorentz transformations. What is Lorentz transformation? As I said in the previous lecture, we have now 4 coordinates for a point. Those points are called event. An event has 4 coordinates: t, x, y, z. But to make all of them of the same dimension, we multiply t by c. So we write the coordinate ct, x, y, z. So say an event is happening. A. Then the transformation of coordinates between two frames, S and S prime. What are S and S prime? S is an inertial frame, S prime is an inertial frame. S prime is moving in the positive x direction. Their origins were coincident at t equal to t prime equal to 0. And the S prime frame is moving in along the x direction with velocity, constant velocity v. If this is the situation, then we call this is a standard Lorentz configuration or a standard inertial configuration. That means a frame is here, other frame is moving along in axis and axis. Here we call it x-axis. It may be the y-axis, it may be the z-axis. In other words, it has to be one axis, not a vector r. That if you move the S prime axis along a vector r, then the transformation is called the what is that called? General Lorentz transformation. And the standard transformation is when the two frames have relative velocity along a single axis. Here we take it x-axis. Now we have how many coordinates? Ct, x, y, z. Say an event. It has coordinate ct prime, x prime, y prime, z prime. In which coordinate? Frame? The S prime frame. And in S frame, it has ct, x, y, z. So we have the obvious question: what is the relation between these two? What is the relation between these two? Or the special relativity principle and the constancy of light together gives you the Lorentz transformation. That is the relation between the ct prime, x prime, y prime, z prime and ct, x, y, z. I have written this beforehand. Ct prime is gamma ct minus beta x. What is gamma? Before that, say beta. Beta is v by c. V is the velocity of the relative velocity of the two frames. C is the speed of light. Beta v by c. Gamma is 1 minus beta square whole to the power minus half. Usually we write it 1 over square root 1 minus b square by c square. So I write it here in a short form, 1 minus beta square whole to the power minus half. So the coordinates are related by what? This is a symmetrical form. You will see other forms of Lorentz transformation Other means only one form is there. Another form, but that is not symmetrical. Here I have written a symmetrical form. Say, see here, ct prime gamma ct minus beta x. If your coordinate is ct prime, the first factor will be ct. Next factor will be x multiplied by beta. If it is x prime, first factor will be x. The second factor will be ct multiplied by beta. So this is a very symmetrical form. So y prime equals y, z prime equals z. Why y prime equals y, z prime equals z? Because there is the relative motion between y in the direction or z direction. Okay. This Lorentz transformation is also called a boost. Boost. What is boost? Boost is something with boost up, speeds up. That means the one frame is moving, so that is a boosting. Okay, we can write this Lorentz transformation in another form. Let we define a parameter called rapidity. Psi is rapidity. Psi is called rapidity. Then psi equals 10 hyperbolic inverse beta. In other words, 10 hyperbolic psi equals beta. 10 hyperbolic psi equals beta. So psi is represented by beta. As beta goes to 0 to 1, beta cannot be greater than 1 because there is the velocity beyond c. V can be at most c, so beta can be only maximum 1, and if there is the velocity, it is 0. So beta, the range of beta is 0 to 1, and what is the range? Then the range of psi is 0 to infinity. 0 to infinity. Psi is called rapidity parameter, and when beta varies from 0 to 1, psi varies from 0 to infinity. Okay. So this form ct prime ct cos hyperbolic psi minus x sin hyperbolic psi, x prime minus ct sin hyperbolic psi, x cos hyperbolic psi, y prime equal y, z prime equal z. So here I need two relations. I am writing that. Gamma equals cos hyperbolic psi. Gamma beta equals sin hyperbolic psi. Memorize these two formulas. Gamma equals cos hyperbolic psi, gamma beta equals sin hyperbolic psi. So these are the these relations are embedded in this formula. Now this form of transformation, this cos sin cos, if hyperbolic was not there, then this will resemble a transformation when there is a rotation between two frames. Two frames, say two frames, two-dimensional frames. Two-dimensional two frames. Two-dimensional two frames. That is x, y, x prime, y prime. Then if they are inclined with one another by an angle theta, then the transformation equation is similar to this equation. So that's why we call Lorentz transformation is also a rotation. Lorentz transformation is also a rotation. Albeit the sine functions are hyperbolic functions here. In ordinary three-dimensional Euclidean space, these are trigonometric functions. In Lorentz frame, in this case special relativity, these are the functions are hyperbolic functions. Good. Now, if you want to find out the inverse transformation, solve this. You will get the inverse transformation. And from here, if you want to the inverse transformation, replace psi by minus psi. In this formulas, if you want to the inverse transformation, then psi should be replaced by minus psi. So these are the Lorentz transformations. Upon these Lorentz transformations, a huge science has been built. The theory of special relativity and all of high energy physics. Now, special relativity is a theory and its application is everywhere. In electrodynamics, in high energy physics, everywhere that you will see special relativity is implemented. Okay? Now, we should discuss interval and light pole. Say we have two events. One event is given by t prime a, x prime a, y prime a, z prime a. Another is given by t a, x a, y a, another event is the subsequently change to v z v prime. We have two events in frame s prime. We have two events in frame s prime. Okay, if we define tb prime minus ta prime as del t prime, xb prime minus xc prime as del x prime, then using the previous Lorentz transformation with psi rapidity parameter, then we can get del s square. This is the nomenclature. We shall explain this later on. C square del t prime square minus del x prime square minus del y prime square minus del z prime square. You see, this is nothing. Forget about for the moment this. The other three quantities plus. If you give plus here, and forget about this, then what is that? The difference between the 2 points. Now here, this we call the interval. The interval between two events in S prime. Because Ct or T has now become a coordinate, so we have to take it into account. And this is the best way to define a quantity del S square given by this. Now, if you use the previous Lorentz transformation, you will write what? You will write C del T cos hyperbolic psi minus del X sin hyperbolic psi whole square minus, this is del T, C del T prime square. This is C del T prime square. minus C del T sin hyperbolic psi plus del X cos hyperbolic psi square minus del Y square minus del Z square, because there is no relative motion in the Y and Z axis, so the primes, this prime square will be nothing but unprimed square, right? And these two terms comes from C del T prime square del X prime square using the previous Lorentz transformation, and work it out for a little while. Work it out. Just complete the square. There will be some terms will be cancelled out, and you put the again Lorentz transformation. You will find that this is nothing but C square del T square minus del X square minus del Y square minus del Z square. What do you see? Del S square, the quantity, which is the interval square. Del S square is the interval square. Given by C del T prime square, del X prime square, del Y prime square, del Z prime square is equals C del T square. Only T prime equal by T. Del S prime square becomes del S square. Y prime square, Y square. Z prime square, Z square. So this quantity and this quantity both are same. These are what? The interval between the two events, this and this. Between two events, the interval square del S square is an invariant quantity. If you take another frame and forget about one frame here, take another two frame, another set of two frames, again you will find this. In other words, this is an invariant quantity. In all of special relativity or space-time. In space-time, this is a geometrically embedded property. Geometrically embedded property. That means the space-time has a quantity called interval. Space-time has an important quantity called interval. That interval is invariant when you transform from one frame to another frame. Say, what is this? You calculate this thing for specified two events. You find 5. In another frame, calculate this quantity, you will find again 5. These are not abstract, these are concrete. These are not abstract. You will find a number. When you work out, you will find a number. And that number is same in all frames. Understood? Good. Now, since del S square is an invariant quantity, del S square is invariant. Del S square is invariant, and there are three formulas divides 3 types of intervals. If del S square is greater than 0, then it is called time lag. If del S square is 0, it is called light lag. If del S square is less than 0, it is called space line. See here, come here. Del S square greater than 0. That means C del T square is greater than the sum of del X square, del Y square, del Z square. That means the special distance square is less than the time coordinates interval square. That's why this is greater than 0 and we call it time lag. Why we call it time lag? If two events are separated by a time lag interval, then you can find a frame where the two events occurring at the same place of space-time. The only difference between the two events is time. That's why it's called time lag. When an interval is time lag, that means you can find an inertial frame where the two events occurring at the same space point. The only difference of interval is given by the time and interval square. If the S square is 0, this is light line. That means there is no difference between the two events. This can be only true for light, because light moves with the velocity c, and c is preserved in all inertial frames. So this is light line. S square equals 0. Two events will not have. If photon moves, photon moves, then interval between two events of that photon is 0. While in a space light, you will find a frame where the two events occurring at the same time but separated by space. When the interval is space-like, then you can find a frame where the two events are occurring at the same time. The difference, the interval is only space-like interval, space interval. The two events are occurring at the same time, but they are separated by space. One is here, one is here. They are happening at the same time. So that's why these three names. And also these definitions. If del S square is greater than 0 in one frame, it will be greater than 0 in all frames. If del S square is greater than 0 in one frame, it will be greater than 0 in all frames. The same goes for the other two. That means these three definitions are what? Invariant definitions. These are invariant definitions. These definitions also carried in invariant way. You cannot find two events separated time-likely in another frame. It is space-likely. You cannot find it. Alright. This definition is invariant. Okay. Now let's see what the diagram would be of these three separations. This is the x direction. We suppress yz because there is no transformation between y and z. And this we call Ct. Because just to make the same dimension. Now let the event is A, an event. Now draw 45-degree lines. Draw 45-degree lines. This is it is in 2 dimension, but in 3 dimension these two lines are round about a cone. In 3 dimension these two lines makes a cone. These two lines makes a cone. Cone. Another cone. This. So now take an event B. This is another event. Now this is future of A. If A is here a point, all events within these two lines and up or in this region, all are future of A. And this is past of A. This event is here, all events below and within these two lines in this cone are past of A. Now, what is the separation, the interval between A and B? Light like or space like? Light like. Take another event. Timeline. Timeline. Another event C. A and C are separated by light like interval. Take another event D. A and D are separated by space like interval. So space like intervals are also called L square. Why L square? That means they are separated by space. They never can be at the same place. They never can be at the same place. Always they are separated by space. That's why it is called L square of A. This is also L square. L square. So this cone is called light cone, and the definitions were given before. Del S square greater than 0, time lag. Del S square is 0, light lag, and C light lag. Del S square less than 0, A and B are space lag. Gone. Now this type of diagrams are called Minkowski diagram. Now we have another mission. We want to see the transformation between two frames. Two frames in a single diagram. Two frames in a single diagram. Say the S frame is this. The S frame. This is the X. This is city. Then draw. This is X prime. And draw This is CT prime. The two frames are depicted in a single diagram. Then the question is, say a event has coordinate x prime of a. This is this x prime of a. X prime of a. Now draw a line parallel to the CT prime axis. In this line, what will be x prime? Same. Then again we can do another thing. Take a time t prime. This is x prime. T prime of a. Draw a parallel to this line. What is here? This is t prime. This is x prime is same. X prime is same. And this line, x line, is the one line of origin of s prime, s axis. Now, what is that? Oh, t prime. Oh, this is right here. All right. The x prime axis has what? T prime equals 0, right? To understand this, follow here. In this axis, x axis, what is the value of CT? In this x axis, the value of CT is 0. Similarly, this is x prime axis. In x prime axis, what is the value of CT prime? 0. Take this axis, CT prime axis. What is the value of x prime? 0. And final point of today's class, this angle theta and this angle theta are same, and is given by tan inverse V by C is theta. The angles between x and x prime axis, CT prime and CT prime axis, is theta, and theta is given by tan inverse V by C. Tan inverse V by C. I am reviewing special relativity, so I shall not do all the calculations. If we go into calculations, it will take a long time. Then it will not be a review. It will be a class of special relativity. So today this much. We shall again meet on, I hope, Tuesday. So far, so good. Thank you very much.